take out our highlighter. And we get the definition of what a radian is. If you have the exact same distance along the edge of your circle as your radius, we have a new way of measuring, which is called a radian. And we're going to explore this idea of a radian. What I'm going to do is I'm going to make the center of my circle here, and I'm going to make a circle with, starting there, with a radius about the size of this. Now I made that radius exactly this, well, I tried, to be the length of this triangle. And I made this triangle, and there's something special. It's a special kind of triangle.
Would that be an equilateral?
It is an equilateral triangle. What makes an equilateral triangle an equilateral triangle? All sides are the same and all the angles are the same, which makes them all how much? They're all the same. Could they be anything but all the same? Can you make a triangle with all 70-degree angles? No, they have to be 60 degrees. Now, if we look at what happens, so if I take a piece of string, measure this, cut it, and then put that string along the edge here, this length would be R, this length would be R. And using this triangle, I can get an idea, because right here, this is exactly 1 radian. But for most of you, you've never used radians before, you're only familiar with degrees. So this will give us an idea of how much 1 radian is. In order to take this triangle and have this side match up with the curve, I would have to bend it a little bit. If I bent this just perfectly to be along the edge of the circle, what does that do to this angle here as I bend it? Well, I can really see if I bend it a lot, it makes it smaller. But I only have to bend it a little bit, so we can start off by saying that 1 radian is a little less than 60 degrees. And as pre-calculus students, this should bother us just a little bit. You know, we're always like, oh, use exact answers as much as possible and don't round early. And now we have this loosey-goosey definition of a little less than 60 degrees. But it's a good visual, right? It can help us see, when you think of 1 radian, you're like, okay, it's a little less than 60 degrees. I can understand why that is using this idea of the triangle. But now we're going to try to be more precise. So one way to be more precise is we can use some knowledge about what we already know. Like if I would go all the way around the circle in degrees, that would be 360 degrees. So now if I go all the way around the circle in radians, I have 1 here, I take that string, I measure another one, I take the string, measure another one, measure another one, measure another one, measure another one. So yeah, we'll start off with there are 6 and a bit radiuses which every radius is a radian. Again, we're not very precise yet. Okay, Callan actually got more precise. What instead of a bit, what do you want her to say?
I have heard of this before. I think the exact amount is about 6.28.
Okay, so about 6.28. So he's saying that my a bit is 0.28. Now, how do we find out what it is exactly? Because yours was about, sounded more precise because you had more decimal places. Mine was like really kind of just hand waving by just saying a bit more.
Circumference.
Okay, so we could use circumference. Because if I'm talking about distance around a circle, that's talking about circumference, and we have a circumference formula. And the thing I don't know if you realize is every time you have a formula, it's a relationship between things. And that relationship means something. In this formula, circumference is 2 pi radiuses. 2 pi is approximately 6.28, 3.14-ish times by 2. 2 pi is exact, 6.28 is still rounded. Okay? But that's what that formula is saying. If I wanted to find out how many radiuses I would need to go all the way around, it's going to be 2 pi of them exactly. And so this means we can now do a little bit of work being exact. We know that 2 pi radians, that's how much in a whole circle, is exactly 360 degrees. How many radians then would be halfway around? If I went only 180 degrees, I would get 1 pi, or just pi, right? Pi radians would be 180 degrees. And if I wanted to find out what 1 radian is, can you see that going from here to here, you'd have to divide by pi? So I do the same thing on this side. $180 divide by pi. And if I go to my calculator and check that, 57.296. A little bit less than 60, but that seems a lot more precise. So when we push it down, it squishes it by about 3 degrees. A little bit less than 3 degrees. This is exact. And this is the idea of radians, and one of the things that happens now in grade 12 and moving into AP Calculus into university is that we start to use Therese, was that you? Can only be explained by ghosts. I mean, that is definitely what happened. Okay. But what happens moving forward in grade 12 now, in AP Calculus or in university, is mathematicians start to use radians more than degrees. And part of the reason that radians is a nicer unit of measure rather than degrees is somebody decided on 360 degrees in a circle. Why 360?
Well, I assume one of the reasons that 360 is has a lot of, I'm forgetting the word. Factors.
It divides nicely, right?
Divides nicely.
Why not use 400 degrees? It divides nicely in 100. We could use a right angle would be 100 degrees instead of 90. Wouldn't that be confusing for you right now? But doable. If you want to do that, switch your calculator to radians. Someone thought, oh, maybe this is good. Arbitrarily make it 400 instead of 360. But it would still be arbitrary, someone deciding to break it up into something. Whereas a radian is based on a relationship. And that relationship is the radius is the same as the radius. And it doesn't matter how big or how small your circle is, circumference is always 6.28 radiuses. No matter what size, how big or how small. Terribly fascinating. Okay, so if we turn to the top of the next page, I would like you to highlight, I find this as probably the most important benchmark. I mean, you could take 360 as 2 pi, but then reducing that half of a circle, 180 degrees, is pi radians. And we already saw here in the blue box that you could find out 1 radian to be 180 degrees over pi. Also, here in the orange box, you could do the same idea and find out that 1 degree is pi divided by 180 radians. And what we're going to do now is we're going to have to switch back and forth between radians and degrees and get used to working with both of them. Early on, when you have radians, you'll probably want to switch it to degrees because you won't be used to it yet, right? If I quickly say, with your hands, could you show me about 130 degrees? Like that? Yeah? Not bad, not bad. Probably you could do 130 degrees, right? With your hands, if I said, do 2.5 radians, to like, put them in my pockets. Right, we're not as comfortable with that yet, so we need to develop that comfort level. And so we'll start with example 1, where we just start doing some exchanges. And I'll show you a couple of ways to do these exchanges. One of the ways that you're going to do the exchanges is to use those 2 things that we put in the box, the 180 over pi and pi over 180, and you just need to multiply by one of those to change it. Okay? The problem is they're kind of similar. So you'll be like, sometimes you're going to be like, ooh, I want to change from degrees to radians. Should I multiply by pi over 180 or 180 over pi? And that can get confusing because they're so similar. So I'll give you some hints to help you remember. If we have 170 degrees and I want to change that from degrees to radians, I'm going to multiply by pi radians over 180 degrees, and not 100 over pi. And here is the following that can help with the reasoning behind that. And I'll start with something you probably already know, okay? If I ask you, how many inches is 2 feet? What is the answer? And what did you do? You don't know because you haven't done feet and inches. Okay, fair enough. And in order to get the 24, you did what? He multiplied by 12 because you have a conversion. You know that there are 12 inches in 1 foot. So first of all, we know that 12 inches is equal to 1 foot. So when he had 2 feet, he said, I'm going to multiply by 12. But in reality, what you're doing when you're doing a conversion is you're using the conversion rate as a fraction. And I'm going to write it with units. 12 inches over 1 foot. If I have units that are identical and I put them in a fraction, technically, if these 2 things are exactly the same measurement, dividing them is equal to 1. So right now, I'm multiplying by 1 here, I'm multiplying by 1 here. But what happens is your units cancel out. And so feet go away, and you're left with just a unit of inches. So in this situation, when I want to convert 170 degrees, and I'm trying to decide, should I put pi radians over 180 degrees or 180 degrees over pi radians, I want the degrees to go away. So I'm left with an answer that's only radians. And this, of course, leaves you with 170 pi over 180 radians. And nice thing in grade 12, you don't have to simplify. If you wanted to simplify, probably in a multiple choice, they would probably simplify that to 17 pi over 18 radians. This, both of these, are exact. So it asks for the exact measure. Exact measure means you leave pi in your answer and not simplify it. It also says to approximate to the nearest 100. So if I go 17 pi over 18, I get 2.97 to the nearest 100. .97 radians. There we go. We're all good. No, this is going to work.
Yeah, this is probably gonna work.
We're going to work well. Okay. So, that is changing. You can use this strategy for any kind of conversion. Probably one of the conversion things that you'll do in your life is if you travel to the United States, you have to do a currency exchange. Or if you're from a different country, right, in your head, you're always sort of like, okay, if I'm buying this in Canada, how much is that in euros? And is this a good deal? Because I know when it's a good deal in Spain, or in Italy, or in Germany, but I don't know if it's a good deal here in Canada until I do the exchange. And then some things are like, wow, that's so cheap in Canada. And other things are like, wow, that's so expensive in Canada. So when you do an exchange, you can use this same idea, right? I look up online right now, 1 Canadian dollar is 75 cents American. And I have 10 American dollars. How much do I have? Well, I can either set up a fraction like this. These are apparently equal. Or I can set up a fraction like this, because they're equal. So if I have 10 American dollars and I want to change to Canadian, I would use this one, because then my unit would go away and I'd be left with Canadian dollars. So I'd be like, oh, I need to take 10 and divide by 0.75 to change. Instead of having to look up something else on the internet that says 1 US dollar is 1.33 Canadian dollars and use that. This tells me if I have to divide. Here, if I have 8 Canadian dollars, I would just be like, well, here I'd multiply this one by 8 Canadian dollars so that my Canadian unit disappears, and then I've converted to American dollars. This works for any kind of conversion. So if you think about adding your units, you can simplify. Okay. So now we can do part B here. And part B, we're going to do part 2 first before we sketch. We have negative 12 pi over 11. We have it in radians, so I'll write the word radians here. We want to change it to degrees. So when I'm trying to think, should I multiply by pi over 180 or 180 over pi?
Yeah, 60 times 2.
I'll put the 180 on the top and the pi radians on the bottom, so that my radians units would go away. What is also really nice in this situation is that the pi goes away.
Oh, I love pie.
I know, it's gone.
You don't have any batteries.
And so if I go to my calculator and I do 12 times 180, 2160, I will get negative 2160 over 11 degrees. It does say round to the nearest tenth, so I'll actually divide this by 11. 196.4 negative 196.4 degrees. One of the nice things about first converting this to degrees is now it asks us to sketch the angle in standard position if I'm thinking in degrees, negative, standard position starts positive XX, this will be 180, right? 196, I'm going to estimate to be a little bit more. So this is negative 196.4 degrees, which is also negative 12 pi over 11. Eventually, we want to start to be able to think just in radians. So if we're thinking just in radians, just like 0 degrees, this is 0 radians. All the way around 360 degrees is 2 pi radians. Halfway around is pi radians. So when we're thinking about negative 12 pi over 11, this is the same as negative 1 and 1/11 pi. If I change it to a mixed fraction. The negative 1 tells me I have to go backwards 1 pi. And then I have to go 1/11 more. So I don't know how good you are at splitting something up into 11 pieces in your head. Imagine 11 pieces. You have to use your imagination that I did them all perfectly the same size. And then this would be 1/11 more. Right? Yes.
You go over the values you put in radians for the different versions we had, like 0, 180, 90.
So 0 is same as 0 degrees. All the way around the circle, 360 degrees, that's the same as 2 pi.
Okay, sorry, I
Okay.
thought that was a point that you had there.
No, it's comma, because that makes more sense then. And then halfway around would be pi. So there we have how we would just think in radians to get that. Yes.
So would half of pi radians be 90 degrees?
Half of pi right up here, or pi divided by 2 would be 90 degrees. And then this one's going to be 1.5, which I'm going to put as 3 divided by 2, or 3 pi over 2, as 1.5. Right? Perfect. Okay. Something. There are some times that you can use the following shortcut to change from radians to degrees and it only works if there is a pi. Okay? The shortcut is as follows. Since pi radians, is equal to 180 degrees. But you're going to find yourself doing what I almost did there. I almost said, since pi is equal to 180 degrees, that is not true. Pi radians is equal to 180 degrees, but pi is not equal to 180 degrees. This is important. This is the same as saying 12 is equal to 1. Well, it's not true. Unless I say 12 inches is equal to 1 foot, then it's true. But I can't just say 12 is equal to 1. But some of you are going to start to think that the number pi is 180. Pi has not changed. Pi is 3.14. Did anybody get the 20 digits of pi last year and get the free piece of pie? Think we should up it this year to 200?
What was the record last year?
I don't even remember.
I don't think it was 200.
Jonathan, what's your record right now? What do you got?
150.
150. So So you'd have to work a little bit to get the 200 to get the pi this year. I think I could do, you know what, that's strategic for the math teacher in charge. Buy 10 pies. Give out a slice of pie if they know 200 digits. Eat the leftovers over the next, might be quite a few days.
And then write it off as a business expense.
Right.
Oh,
Health expense. Okay. So, if we had 3 pi over 4, the shortcut says I can just, in radians, is equal to 3, I can change the pi to 180 degrees. This will give me 135 degrees. The reasoning why? Well, look, if we do it the proper way, 3 pi over 4 radians, I'm going to multiply by, put my radians on the bottom, so pi would be on the bottom, and 180 degrees on the top. Well, the radians would go away, the pi's would go away, and can you see that basically what happened is the 180 replaces where the pi was. And so it can be a shortcut that you can use if you're changing from radians to degrees and you have a pi. You don't have to use that shortcut, you can still use the fractions just to say. Yes.
Do you have to write radians every time, or is there a shortcut like that?
That's a good question. So, degrees, the symbol for degrees is the little tiny little circle. Do you know the symbol for radians? You guys are amazing. Every single one of you said nothing. And that is actually the symbol for radians. Wow. So when we want to write radians, and so far I've been really I've added the word radians, but you're kind of like, well, that's kind of annoying. Shouldn't there be like a little symbol that I can use? And the answer is no. When we want to write an answer with radians, we technically don't have to write anything.
What?
Doesn't that bother you a little bit? Right? If you forget the degree sign, you would lose an E5 error for not including units. And when radians, you have to remember to write nothing. Which feels a little weird, right? In fact, I know a teacher that bothers so much, they invented their own radian symbol where they do a degree sign with an R inside of it. But that actually doesn't exist. So radians is the only thing in all of mathematics which has a unit that you don't have to write the unit, just to mess with you a little bit. Right? Maybe someone thought about this, but then students would be like, here's 70 degrees. Well, is that a degree sign or a radian sign? Well, you have to look really closely. If you look really closely, I have a tiny little open circle there. And for this one, there's a little R in there. You just have to trust me. I'm not sure. So there is no symbol for radians. Just kind of, but this is why it was so important in previous years that you had your degree sign included. Because for example, if you wanted your answer to be like 70 degrees, or even let's just do 180, right? I'm skiing, I do a jump, I do a 180. Now, everybody assumes degrees, I meant radians. Okay? 180 in degrees is just a half a turn. 180 in radians, if you think that all the way around is 2 pi, which is 6.28, 180 would be like a little close to 30, a little bit less than 30. It's like doing a helicopter in the air before you land. So it means something completely different when you don't include the degree sign. Now, you didn't know that when you did your trigonometry in grade 10 and 11. But as a teacher, I look at your answer, I'm like, oh, you means the answer you wrote is completely Like it's so far off, just because you forgot the degree sign. Now part C we can't use the shortcut because there's no pi. So it starts off with 7.5 radians. We would have to multiply by 180 degrees over pi radians because we want our unit of radians. So sometimes I write it out there, but we could, now that we know we don't have to write anything, right? We could do this. And then cancel out the invisible unit that's there. The invisible unit went away. And we're just going to be left with, now that's confusing, so I'm gonna still write rad.
The invisible unit is real, it can't hurt you.
Yes.
If I just wanted to write rad on anything, would I lose?
No, you'd be fine if you wanted to like for
Okay.
your, right, or rads. Sounds cool. Right? I think I was, trying to think if I was in elementary school or middle school when the word radical meant cool for the first time. Right? Is it still in your vernacular? You're like, oh, that's so rad. Probably, yeah, you use that every day, right? Only if you want to make a math joke.
Very rare.
Oh, there we go. This is good. New seating plan. You're going to be at the front. You know that.
Good.
Yeah. So we can.
I would like to keep this one here.
Yeah. Well, we might move you different in the front, but we'll see. Okay. Questions? Oh, we should actually simplify this. So if I do 7.5 times 180, 1350. This technically is the exact value. If the question asks for an exact value, and I'm now in degrees, so I have to include my degree sign. If it asks me to round, which I think it does,
The nearest 10.
to the nearest 10, divide by pi, 429.7. Excellent. And your questions for practice on this one are 4, 5, and 7. Ooh, one other thing I wanted to do, which I think you have space at the top of the page beside no, that's not where it is. Beside this, right? You have some space right here. Okay? In that space,
4, 5, and what?
4, 5, and 7. In that space, the formulas we discovered yesterday was an arc length formula, and we discovered it in degrees. Okay? I'm not sure why, but the letter that we use for arc length is S. Arc length. I think S. Probably because A was already, you use A so much already for area. So after A comes S. What did you say?
Acceleration.
Acceleration. Sure, in physics. That's a little a though. So S for arc length, and we already figured out that it was a proportion saying whatever proportion your angle was out of 360 degrees times by your circumference. And now we can also make an arc length formula if you had a question in radians. It's the same idea. You have your angle, it's in radians now, but then instead of out of 360 degrees, well, how many? That is exactly equal to 2 pi radians. And then again, multiplied by your circumference. And you know how yesterday I said we should not reduce or simplify this equation because I like how it has meaning in this form, okay? I would also agree that we probably shouldn't simplify this one, but mathematicians couldn't help themselves. Because look how juicy a simplification this is. Like, do you see that the 2's are gonna cancel out? And the pi, like, because like, I can't help myself, I have to cancel that out because it's so easy to cancel out. And the formula, and this one is on your formula sheet, is so simple a formula. The arc length is just theta, the angle, times the radius, but this works in radians only. So favorite pastime of the final exam is to ask an arc length question, but make sure they give it to you in degrees. Because the degrees formula is not on your formula sheet. And see if you're tempted to use the formula that won't work, because it only works in radians. It's going to happen. Okay. Stop our video here.